Hi, I'm Mathieu Hellegouarch and I work at DHI as a product owner for MindPlus. In this video, I will demonstrate how to get cross-section views from 2D Overland models. With 2D Overland models, ground levels are defined either in a mesh file or in a grid file. This input topography file is well suited to display a map of the elevations, but it's sometimes very useful to be able to see a cross-sectional, meaning a vertical view of the topography, for example to verify how well the local variations of topography are described by the mesh. Besides, your simulation results will provide water level results in another file. And when you couple this to a 1D model for rivers, you also get another source of data for the river. So I will also show you how the MindPlus tools can combine all this data into a single cross-section view. In this example, some areas are modeled in a 2D model only, whereas others are combined to a 1D model describing the rivers with the blue lines here. This example contains dike structures with the pink lines, which control the flow between mesh elements, but presently these crest levels will not be shown in the cross-section plot. At first, I will show how to look at input ground levels only. From the 2D Overland tab, I will select this 2D cross-section plot. Please notice that in the flyby text, you will get a description of how to use the tool to digitize the location of the plot. Here I can select which options or which kind of data I want to plot in my cross-section view. I will start showing the 2D elevations, possibly with river cross-sections. Here I need to select the constant spacing. This spacing should be consistent with the length of the smallest mesh elements. The tool will find ground levels at regular intervals along the cross-section location. With flexible meshes, like in these examples, you may sometimes get several points in the same large mesh elements, or on the opposite, you may miss some mesh elements if the spacing is large compared to the mesh element size. Then I can start digitizing and I can draw my cross-section view wherever I want, drawing a polyline. Just double-click and elevations from the 2D mesh will be shown in the cross-section plot. Here we go. We have our first cross-section view showing 2D data only. I can keep it opened. And I will now create a new 2D cross-section, but this time combining with a river cross-section. To start drawing such a cross-section, I will hold down the Control key and start digitizing. Now I can release my Control key and I will snap to a river cross-section, which is my red lines here. The tool will understand that this cross-section must be merged with the 2D cross-section data. I double-click, wait, and a new cross-section view will show up, this time showing both sources of data. If I expand my view again, so here I can stop digitizing. You will see that we have markers showing the locations or the boundaries of the 1D cross-section. In between these markers, the constant spacing is not used. The cross-section will show the exact points from the 1D river cross-section. Now, I may also want to compare a cross-section from the mesh with a raw layer of elevation data. So I can select here my DEM. I have already selected it or loaded it on the map. I can show it here. So if I also select this option, I can select which DEM layer I want to add. And the same, I can also select a spacing which can be different because here the resolution will probably be finer. So I can say I want a spacing of 2 meters and digitize a new cross-section. So now let's compare in the 2D domain a cross-section. where I will compare the elevations included in the mesh used for the simulation with the raw data from my input DEM. So this can easily be used to evaluate whether the mesh resolution is acceptable or not. So here we are. We have now a second line in green showing the input DEM, and you can also see the actual elevation along the line in the tooltip. To continue, I would also like to highlight that there are some extra options in the context menu. So here you have the usual options, but you can also export to a text file that will save a text file with all the data, the elevations along the profile, and you can also save the location. This is useful to save the coordinates of the cross-section into a text file for later reuse in order to be sure that next time you can load the same cross-section from another source of data, but really with the same coordinates. So once you have saved the location to a text file, the next time you use the tool, you can change the option to load the location from this text file. I will now show a second but very similar tool, this time used to show water level results in the cross-section. So I will first zoom to an area of interest. And now from the Results tab, I will select again the cross-section plot tool. And you can notice that again, you will get information about how to use the tool for digitizing the cross-section location in the tooltip. From this window, I have to select first which result files I want to use. I may have loaded many of them in MindPlus, but in this example, I only have one choice because I only have one 1D result file and one 2D result file loaded in MindPlus. Again, I need to select a constant spacing, which is only going to be used for the 2D cross-sections. Because for the 1D river cross-section plot, the raw points from the input cross-section will again be used. Click OK. And in case I just want to display a 1D cross-section, I just need to make a single left click on the cross-section, and I can see my river cross-section view with the input elevations, markers location as defined in the input cross-section, and water level result, which is constant here in the 1D domain. Now I would like to continue with a combined 1D, 2D cross-section. I will again increase my spacing here because I have large elements. I can even increase further. And I will start holding down the Control key. Then I can release the key. I digitize my location, snap to the 1D river cross-section, and continue digitizing on the other side in the floodplain. Now I can double-click to end digitizing, and MindPlus will process all data. So what it's doing now, it's fetching 1D data from the 1D result file, and it's also fetching elevations in the 2D domain from the input mesh file. And finally, it's fetching 2D water levels from the 2D result file, and then combining everything in a single cross-section view. I can also add that, of course, it's also possible to display a pure 2D Overland cross-section view. You don't need to combine with a 1D cross-section. This is just optional. So now we have our combined cross-section view. So you can again see the marker locations showing the limit between the 1D domain and 2D domain. And here you can notice that water levels are varying in space along the 2D area, while it's constant in the river cross-section. And of course, these results here are synchronized with the results shown on the map. So when I move my cursor here, it will change results both on the map and in this cross-section plot. This is all for this demonstration. I hope it was useful to you. Thank you for watching.